material today, then I'll end, make sure that I've got new material in, and then we'll take questions on, you should have some really great meaningful questions on your homework. You're starting to run into what'll happen on almost all your homeworks where you're having to make some decisions on intervals, and you can make faster decisions. Caroline saw yesterday also sometimes it's good to move on and come back to it, because there was one I was actually working on, which happens sometimes. Then I'm like, well, I'm just gonna go and get another sheet of paper and start over, or look at something else and come back to it, because sometimes you're just gonna stare at it and not think of it until you come back to it. Granted, if you're on the test, you may not have that luxury because you gotta finish. Okay, so first thing I'm gonna do is teach you a formula for, or teach you how to find your derivative of an inverse function. So you have a function and you want its derivative, but also sometimes you have a function and you want the derivative of its inverse, okay? So let's say if I had y is equal to 3x plus 4. We'll start out really easy. And I have the point 1, 7. And many times we call this f, and an inverse f of negative 1. I hate that notation because I'm going to need the derivative of the inverse. So I'm going to have like that up there, and it's going to get confusing if I want the, that's just weird to me. So many times you'll find in the AP program, and myself, I follow suit, that a lot of times we call the original f and we call g the inverse. But then I don't want you to think that f and g are always inverses of each other. They are not. It'll have to be laid out in the problem. Like g is equal to f to the negative 1 power, or f and g are inverses, or even I've seen it done like this, where you're told f of g of x equals x. And they think they're telling you these are inverses of each other because that composite function only happens with inverses. So if you're told f of g of x equals x, or g of f of x equals x, that only happens with inverses, okay? All right, so suppose that I'm gonna call this f, and I'm gonna define this, and I want you to find g prime of 7. All right, so that's our goal. So let's find the inverse. Let's switch x. Well, first of all, let's find the inverse. So let's switch x and y. And then let's solve for y. We don't really have to because we know implicit differentiation, but most of y'all probably would. So I'm going to have y is equal to x minus 4, and they're both over 3. So y prime, and somewhere you need to say taking the inverse, and I'll show you that. That gives me 1/3, I think. Is that right? Okay, I think that's right. Okay. So the derivative of the inverse was 1/3. There was something else I wanted to show you there, and I can't remember what it is. Okay, I'll go on. A few things about this. 1, 2, 3, 4. The y-intercept of the original is 4. And I'm going to go up 3 over 1 or down 3 back 1, so the line looks about like this. If I graph the inverse, the y-intercept is negative 4/3. And I'm going to go up 1, so from negative 4/3, I'm going to go up 1 to negative 1/3 and over 3. And graph this. And we've said this before, if they're inverses, they should reflect over the line y equals x, which you learned in your algebra class, okay? Those are inverses of each other. This all was super easy, obviously, because it started with a line, okay? But it only works nicely. Inverses only work nicely if the function's 1-to-1. So you might know what I mean by that. Yeah. Okay. So 1-to-1 means that this purple would have to pass the vertical line test and the horizontal line test. So what are some inverse functions that we dislike? I sort of dislike square root. That can trip me up when I look up my answer in the back of the book. I also am real unhappy about inverse sine, cosine, and tan, right? Because they're persnickety, okay? So if a function is 1-to-1, you can easily switch all your x's and y's Now, when you do the horizontal line test, you're checking to see if any of your y's repeat that are about to become your what? X's when you take the inverse, okay? And it, inverse function, and certainly know by now, even with derivatives and integrals, they undo each other as best they can. I can't say now anymore after Algebra 2, pre-cal and calculus that they just undo each other. A square doesn't just undo a square root. Arc sine doesn't just undo sine. It helps you some, but then you got to do the rest of the work. But anyway, do you see that this is a pre-vertical line test? So that tells me the inverse of x cubed, the cube root of x, is also going to be a function, and you can relax. It means it's not going to be hard to find answers, okay? But what about x squared? Is it a one-to-one function? It's a function, so everything's fine with x squared. You and I are not scared at all of squaring things. But is it one-to-one? It's not one-to-one. In fact, this inverse function, all we have is this, the square root of x. It does reflect over the line y equals x if I get rid of this part. Okay, do y'all see what I mean? So what happens is if I really switched x and y, I would get this, which ceases to be a function. So that's why they only gave you the positive portion for square root of x, so it's very limited. So it can be kind of dangerous. Okay, now, why are sine, cosine, and tangent so treacherous when you get to their inverses? They're functions that I'm not scared of taking the sine of something. I'm a little on my toes about taking the arc sine of something, or even what the graph of it looks like, or what in the world is going on. The reason that that's a problem is because it's by far not one-to-one. So when you switch your x's and y's, it will not function. And so they had to find a sliver of it that would function and give you kind of a heads up. Almost kind of like a reference angle or something. Did y'all see the problem? We're about to run into that problem here, okay? All right, now, let's say, I'll probably should just do an example in the book instead of make one up. Okay, so let's go on to another slide. All right, so your book goes through, actually your college calculus book, this college level book actually goes through reminding you all that I just did for a few pages, just about inverse functions. Because they know that students a lot of times don't have the maturity to, I just went through like basically 2 years of mathematics in a minute and a half, and y'all are nodding your head, and you're like, okay, I get it. But saying it again kind of, maybe hopefully solidifies it, makes it more solid in your head, like, okay, like I didn't get all of that. When I was going into calculus, I thought I did, but I didn't process all of that, and why I disliked inverse functions, and why in the world can't smart people that program my calculator manage it better, why when I push arc sine of 1/2 is it only going to give me 30. Now, I understand why, okay, because it's not a one-to-one function, and they had to make a choice to give me 30 or 150 or 390 or negative 330, or they had to make a choice, okay? Because there's so many answers since it wasn't one-to-one. Okay, so now you may think, okay, next, I got that, I'll switch x and y, solve for y, take my derivative, okay? There is a formula that I usually derive. I don't know how to derive. Sorry, I didn't think about it before I came in here. So I may not derive it for you today, but the disclaimer there is I said I wasn't going to derive everything. It's easily derived and it's not clicking in my head right now. Anyway, I'm sorry. If f and g are inverses, only if f and g, if you're told they're inverses. F and g are usually non-inverses, but if you're told they're inverses, then the formula for g prime of x is 1 over f prime of g of x. That's what drives me crazy. But anyway, I'll derive it in the next class. Oh, okay. Maybe it's this. Oh, good. All right, your teacher's going to come through here. All right, so if I do a composite function, if they're inverses, this should always happen, right? Okay? So if they're inverses, that's a true statement. So let's take, y'all ready? Let's take the derivative of the inverse, okay? I'm sorry, time out. so excited about it. This is a true statement only for inverses. Alright, so I'm about to take the derivative of a true statement to see what happens. That's all I'm doing. So this is a statement about inverses. I'm going to take the derivative of that statement. So I'll use the chain rule, f prime of g of x, and go back in for g prime of x. And what's the derivative of x? 1. And so I'm looking for the derivative of the inverse. So let's solve for g prime of x. And I get 1 over f prime of g of x. So that's how they got it, chain rule. I forgot how they got it. Glad I pulled that one off. Okay. 1 over f prime of g of x. Alright, now that's kind of hard to read. You have to know which x and y you're talking about. This can get tricky. Now, with a linear function, I can't really show you because when you take the derivative, we get slope, right? And so whatever the slope of the line I gave you was 3, the slope of its inverse was 1/3, and you know, that just doesn't really even, I didn't have to even use my point. Did y'all notice I didn't use my point? Because the derivative was a constant, so I'll have to go with something else. Anyway, if I have a point 4, 7 on F, what will that point become on G? 7, 4. Okay, the x and y will be switched every point for point for point, okay? So you've got to be careful that you know what you're doing here. If I ask you for g prime of x, what x are they talking about? Are they talking about 4 or 7? You've got to really look at what function you're on. You're starting out with g of x. So they're talking about 7, okay? Now what is it? What is g of x in my situation up there? G of 7 is 4, okay? Then I have f prime of 4, which I can easily take. Are we okay so far? I'm trying to think about that. I'm going back to that line. That's sort of odd. Oh, that would have worked. Okay. So on the line that I had, by the way, the reason I'm sort of pausing and stumbling through this is the way that I do it. I don't usually use the formula. I usually use something else. One thing that I can use, y'all just saw me do it. I did it before I ever taught you a formula, right? I switched x and y, I just took the derivative of it, so game over, let's move on. However, there's going to be more to it, of course, so just wait for that. There are times I need the formula also when they give me a table of values and I have no equation. Make sense? Okay. But it would have worked. If f was 3x plus 4, and I know I want the derivative of g prime of whatever number I put in there. It wouldn't have mattered since it was a line. G prime of x would have been 1 over f prime of g of x. But what is f prime in this case? It's just 3. You never even get to that. It's a constant. It's just 1/3. If y'all remember, I got that on the last slide. So it's 1 over 3, and there was no x. There was nothing to fill in. One thing that's going to happen though, this right here, g of x. What's another word for g of x?
The inverse.
Another word for g of x. What's another word for f of x?
Function.
Y. Okay. So this g of x. Really sorry, that was such an open-ended. Just trying to see if you can name everything you could think of. That was like playing a game show. Okay, so g of x, another word would be y. So you're really putting the y value of a function in. And so I better do it. All right, but why do I even need a formula? Let's look at this. Here, we'll move them. Didn't she look like she's like 26 years old or something? That girl right there?
I think that was the girl with the flashlight. I wanted to ask her what blush she is, but then she had to go.
I can ask their sponsors to ask if we can narrow down the girl. Okay, so what if I have y equals x cubed minus x plus 2? And this is a function, we'll call this f. I'll tell you g is the inverse of f. Our book actually uses this notation a lot. I'm okay if you use g of x in your homework, it's just make your own decision, okay? If I fill in, 1, I get 2, okay? That's on the original. You have to really watch where your point is. That point automatically becomes what on my inverse? 2, 1. So this is all about f, this is all about g, okay? But say I don't want to learn that formula, and also my teacher's already told me that it can be confusing, okay? So I just don't want you to use it. I'll just, if I say find the derivative of the inverse, I'll just find the inverse and take its derivative, right? So what's the first step in finding derivative? Switch x and y. So you have y is equal to, nice if I switch them. So you have x is equal to y cubed minus y plus 2. Next step? Solve for y. Can you? No. So all of a sudden you're like, whoa, I can't solve for y.
Can you take in terms of that? Implicit difference.
Y'all are so awesome. The first person, and there's a rare person that says that. Is that what you were thinking too? Implicit?
Oh, yeah.
Okay. So Emma and Morgan, very rarely does someone even think of that, including myself. It's so embarrassing. Okay, so up until the late 1900s, which time I had already taught for a long time, I was this like AP calculus teacher at the rival high school of the one that came this morning. So they call it the school across town because they won't even say the name of it. But anyway, I was at Jackson Academy instead of Jackson Prep. And teaching at Jackson Academy, 2 of the smartest people I've ever known in my life were the twins, Brad and Ken Ball. But I had taught derivative of the inverse. I learned from Dr. Staten when I was in college the formula for the derivative of the inverse. So I'm teaching it the way I had learned it. I'm teaching the way it is in the book. I'm teaching the way it is in our Larson text. And I get there and I go, ta-da, so now that's why we need the formula. And Brad raised his hand, who's now a doctor, he's a surgeon, I think. I'm not sure what kind of doctor he is in Colorado. But anyway, Brad raised his hand and he goes, why don't you just do implicit differentiation? And I stood there after many years of doing calculus and kind of looked at him like, will that work? Why in the world would that not work? So Emma, you kind of stole my thunder there because I wanted to move on out of that slide. But I never know if somebody's really gonna see that. That was awesome. So I'll switch it from Brad to Emma and Morgan. Yeah, you could go on. I'm embarrassed that I thought, oh, well, I'm stuck. I can't solve for y, therefore I cannot take the derivative. When in every class up until that moment, I had already taught implicit differentiation. Some of you others may have thought that too. Of course, that's how I should keep going. So you once again should think, well, then why do I need your stupid formula? Really, the reason you need the formula is because of the way they ask AP exams, or because people in research really many times are only dealing with data. One thing we're talking about in my pre-cal class, not my honors, but my regular class, they're having to take data and write equations of sinusoidal functions. And we kind of laughed about it yesterday, like if your parents are engineers or research scientists, they don't come into work and people hand them a worksheet and say graph these functions, okay? They're looking at data and they're writing mathematical models for the data. So many times all that someone has is data and they might need to know how the inverse is behaving. And they only have data. So you need the formula for data or for like a multiple choice where they've set up your formula. Okay, let's go ahead and finish this one. And then we'll try it with the formula and we'll compare. So thanks to students that I have, let's keep moving. The derivative of x is 1. This will be 3y squared y prime minus y prime, and the derivative of 2 is 0. So did y'all see what a few of y'all were saying in terms of x, implicit differentiation? Grace, I think you're headed that direction too. So now I can solve for y prime, okay? Oh, this is prime, right?
Yeah.
Okay. So I have 1, not ready for that yet. So I have 1 is equal to 3y squared minus 1 y prime. So it's a good review of implicit differentiation. So I get y prime is 1 over 3y squared minus 1. Now you have to be careful that you know what function you're on, okay? Right now I'm on the inverse of the original. I'm on the inverse. And the reason I've talked about it can be confusing is just so you would be on your toes so that you'd see what I'm about to do, because I think you're intently listening like, where's the confusion come in? I've got to fill in Y. Who's Y? 2 or 1? All right, I've already switched X and Y. As soon as I switched X and Y, I'm on this point. Do y'all see what I mean? All right, so the derivative at this point that we're talking out would actually be G prime of 2. G prime of 2 is equal to 1 over 3y squared minus 1. So I get 1 over, be sure you put the correct y in. And so I believe I get 1/2 for the derivative of the inverse function. All right, now let's try to use the formula with that problem. All right, so help me remember, x cubed minus x plus 2 at the point 1, 2. All right, so I have y equals x cubed minus x plus 2 at the point 1, 2. Can y'all see that okay? Am I right the rest in blue?
Blue.
Okay. Minus x plus 2 at the point 1, 2. I make note to self that when I find the inverse, it immediately becomes 2, 1. This is my original, and this is whatever notation you're using for your inverse. Okay? All right, so if you're just going to use the formula, or you're being made to use the formula, you're going to say g prime of x is equal to 1 over f prime of g of x. So the good thing about the formula is, which is what I thought back in the 1900s and the 1990s, that I was going to really say, so we've got to learn the formula, but we really don't if we have an equation. But my point was, if you can't solve for y on the original, you really never need to with this formula. Do you see you just need f prime? So let's go. All right, so this is f of x. This is the original. And so f prime of x is 3x squared minus 1. So I'm going to say 1 over 3x squared minus 1. Now I have to be super careful. This is 1 over the derivative of the original, so you never have to find the inverse. Like, I don't have it written on this board anywhere, okay? F prime of g of x, so let's work from the inside out. G of x is actually asking for the y value of the inverse. When they say g of x, they want you to, you're right here, right? So g of 2 is 1. And I filled it into f prime, and I get the same answer, same result. There's a little bit of different variable, but you get the same answer, okay?
Wait,
All right.
can you backtrack? Can you go over that again? Sorry.
Yeah, so you'll learn the formula, 1 over f prime of g of x. And you gotta see what function you're on. They're taking you over to g, okay? In fact, this problem would actually have said g prime of 2, to be quite honest with you. They would have already gone to that point, g prime of 2, and so x is 2. When you're on function g, you're talking about this point. So if x is 2, what is g of x would be 1. So I put 1 in there. This is asking for the y value of your inverse.
Oh, yes.
Okay, remember how in class I was like, what is g of x a few minutes ago, and people
Yeah.
were naming all this stuff? I wasn't very clear. Another word for g of x is the y value. You just have to know which y value you're talking about. Are you on f or are you on g?
So the one that you just plugged in, that's from the point 1, 2 on f of x, right?
I'm on 0.21. Okay? Because let's take it slowly. So right here, this sends me over to the inverse. Okay? And they want g of x of the inverse, which is the what value?
The y value.
The y value. So I'll put in the y value, 1.
Okay.
The y value of g of x.
Yeah.
See, it's right here.
Yeah.
Here's the x value, here's the y value. Which one did they want me to fill in here?
Y value.
The y value, how do you know which function?
So it's g of x inverse.
So I just put in the y value of the inverse function. Okay, so that's what the formula is saying. they really want the y value, which is actually the x value of the original. Like I said, it can get confusing. Alright, so let me do one out of the book, because I think they word them really weird, actually. Okay, so I'm doing number 72 out of the book. Alright, so this is number 72. 72 says f of x is equal to 5 minus 2x cubed. And a is 7. Now we're throwing an a at me, okay? A is 7, but they tell us this in the book that you're given a function and its inverse. So they're calling it f, and f the negative 1. I'm going to call it g, because I don't like writing f to the negative 1 prime. Alright, so this is the wording you have. Verify that f has an inverse. Then use the function of f and the given real number to find this. So Caroline, we're looking for this. G prime of A. Okay? Not just Caroline, but you gotta get your point straight. Okay, if I want G prime of A, all of a sudden they're calling this A value the X value of my inverse. Do y'all see how I'm putting that together? Because A value could have been an X, a Y on any of the two. It could have been 4 different things. It could be the X, the Y, or the X or the Y of the inverse. How do I know it's talking about the inverse? Because it said G prime of A. So the point 7 something is on the inverse. So this is actually going to be the Y value of this. Can you think what X would have to be to make that happen? -1. They'll give you, if they do it this vaguely, they'll give you something you can figure out. Y'all see Grace got -1? Alright? You could actually do some algebra on that one, but some of them you can't even do the algebra, you just gotta think like, on this one, it'll be pretty easy. Like that, that's a 2, I'm sorry. A 0 gives me 2. Do y'all see what I mean? Alright. So now, let's do it first with the formula. You can choose. Don't do it 2 different ways. Say you like the formula. All right, so I'm going to say 1 over f prime of g of x. I'm going to write my point down. It goes from being -1, 7 to 7, -1. So I'm going to say 1 over f prime of g of x. Your instructions were to find this. So I'm finding g prime of A. So I'm finding g prime of 7. So if 7 goes here, it also goes in here. It's the x value of my inverse. And this will probably be more clear than the last one since I actually am filling in the number. Now what is g of 7? -1. And that's going to be my answer. So let's find the derivative. F prime of x is -6x squared. So I have -6x squared, and I fill in -1. And my answer is -1. So what's happening here is this is the x, which forces you to get the y on your inverse, which is actually the x value of your original, if you follow the chain of events. Obviously don't like this one, but I have to use it sometimes if I have a table. And we'll run into those, okay? Now let's see, remember we got -1. Let's see if we get -1 a different way. Because after that moment, I quit focusing a lot on the formula that I feel like I must know, and I think back to, why am I doing that? This is y is equal to 5 minus 2x cubed Let's switch x and y. That's not a division. X is equal to 5 minus y cubed. And just take the derivative of the inverse. Do y'all see right at this moment I have the inverse? Now we still have that problem though of getting it straight in our mind. They said at a equals 7. And somehow, some way they've got to tell you where that is. Is that on your original or on your inverse? Sophia? Oh, did I mess up?
You forgot the 2.
The 2, thanks. Okay, thank you. Anyway, they said find g prime of a, so I knew a, which was 7, was right here, okay? It was the x value of my derivative, which meant it was the y value of my original, so I still had to do the work to find the rest of the point. All right, so this is 1 is equal, the derivative of 5 is 0. This is minus 6y squared, y prime, implicit differentiation. So it gives me y prime is equal to negative 1 over 6y squared. Which y are you going to use, the 7 or the negative 1? Well, from this moment on, you're on the inverse, right? So you're going to use negative 1. Did I lose a 6 on
Yeah,
the?
you lost a 6.
I lost a 6 on the other one, sorry. I'll hit undo after you look at that. I should have negative 1, 6 both times.
Just like didn't do the 6.
Here's a 6.
Like when you just squared x, you just and didn't put the 6. In the last
Like right there.
yeah.
Well, I should have and I didn't even put it under 1. I hate the formula. Okay, so let me redo that again. I'm glad I did it both ways. The formula is 1 over f prime of negative 1. So you get negative 1, 6. I just totally messed that up after I wrote this statement down. 1 over the derivative with it filled in. So we didn't go over homework, but we will. I'll just I'll slow down and maybe move my topics around. Now, I want to end the last minute actually with making sure you know the trig derivatives also. I'm sorry, but all 6 trig integrals, which every last minute of the class I know I do, but here they are, okay? I know you feel like you have a lot to get used to with the logarithms and exponents, and I keep trying to give you problems that give you that kind of practice. All right, so if you want to take the integral of tangent u, it's either negative ln cosine u plus c or ln secant u plus c. If I want the integral, and by the way, these are all on page 339, all 6 trig functions. The integral of cotangent u du is ln, I have to look at it myself, cosec should be ln sine u. I knew it had something to do with cosecant. Oh, there is a cosecant one. Or negative ln cosecant u plus c. When you don't have multiple choice or anything, you can pick whichever one you like. The integral of secant u is, double check it, ln secant u plus tangent u plus c. These are on 339, and cosecant u is ln, and you just memorize these, unless you had some horrible, dreaded reason that you wanted to verify them every time. Sorry, I put the negative in the wrong place on the last one. There's a negative out here, not right there. So it's right here, negative. And you'll have a few problems that make you apply these patterns. So these are the same of something I've showed you before. This is a -1, and if you move it up here, it becomes cosecant to the -1, which is the same thing as sine. As you're packing up, I'll post homework in a little while. The way I remember them, I just flat out have to memorize them. But these two are helpful in the derivative of secant, a secant tangent. So the antiderivative has that ln, but it's all got secant tangent in it. Do you see, but they're added? And you can keep going. The derivative of cosecant, isn't it negative cosecant cotangent? So do you see there's similarities with a plus sign thrown in? It might help you memorize the last two.
Thank you.
All right, bye girls. I'll post homework. Oh, and Tuesday, I'll remove whatever, I was gonna do that day and just take lots of questions because I think the test is Thursday.
It's
We
Friday.
passed Wednesday.
Yeah, we have this.
Oh, it's Wednesday and Friday. On Wednesday will be a big question day. You have almost a week to ask me questions. You can email me this weekend or see me Tuesday.